because the one that I have on there currently, that's a really old one. So I think it needs to be updated with the material. Now, when I say arithmetic series, so there's our objectives and our standards. We know what an arithmetic sequence is. That's what we've been dealing with the common difference. We're growing by units of 3. We're adding 3. Everybody agree with that? Okay, grab your calculators. What if I asked you to, everybody's calculators out, you need to be active participants. I already know how to do it. I don't need to work them out. Fair? If I said find the sum of the first 10 terms, go. So find the sum of the first 10 terms of this arithmetic 175, right? Y'all good with that? You're comfortable with that. But what if I ask this? What's the sum of the first? You know what? Better yet, what's the sum of the first? Let's scribble that out. The sum of the first 100 terms. Now that's going to get tedious, right? Okay. So first of all, let's make sure we understand this. A series is the indicated sum of the terms of a sequence. So an arithmetic series is simply the sum of an arithmetic sequence. So if I say what's the arithmetic series of the first 30 terms, you know immediately I'm talking about finding the sum of the first 30 terms of an arithmetic sequence, right? Common sense. Now, back to this problem that we were talking about. Find the sum, I'm going to go back to it here, of the first, instead of 30, let's say 100 terms. Legend has it, Johann Gauss, who is a famous German mathematician, legend had it that his first grade teacher wanted to give the kids a project that would take them a little bit of time in first grade. Let's just think about it. And he said, guys, I want you to write out the first 100 terms, and I want you to find the sum. So let's think about for a 6, 7-year-old, that's quite a tedious assignment. Would you agree? The teacher turns his back, and Gauss yells out the correct answer like in 10 seconds. Teacher goes, how'd you find that so quickly? How'd you know that? Yeah. Obviously no Google, right? Back in this time. Well, what he said was, Gauss, now understand he's a prodigy, he's brilliant. He said, I know this. So look up on the screen here. He said, well, I know the first term's 4, the next term's 7. Can you, so can I deviate a little bit from what the teacher had? He told him, I messed up my story. He said, just find the sum of the first 100 numbers. So he was saying of 1, 2, 3, 4. Y'all with me? Which is still very extensive, right? And so ... Let's get to the end. Let's go 98, 99, 100. Okay, everybody see me? And what the young Gauss saw was, he said, well, if I went 1 plus 100, that's 101. 2 plus 99, that's 101. 3 plus 98, that's 101. 4 plus 97, that's 101. And the Gauss said there's 50 combinations of 101. So I just took 50 times 101. Everybody take 50 times 101. What is it? 5,050. That's the sum of the first 100 terms. That's where this formula that I'm going to pop up to you, that's what he did. So I want you to, can I manipulate this formula a little bit? I think it's easier for you guys to see it like this. Instead of putting the 2 there, let's put the 2 underneath the n. And as you're writing it, look up and understand this. See how he went the first term plus the last term? 1 plus 100 is 101. There's 100 terms in this sequence, 100 divided by 2, 50 combinations of 101. That's where that formula is derived from. Now, how accurate legend is of Gauss doing that, that's debatable, right? On that, they talk about the legends and things like that. But there's our arithmetic series. So let's look at this now. Knowing this, n over 2, first term plus the nth term, let's use that to find, and let's do 30 now of this sequence that we had before. I need to find the sum of the first 30 terms, which is going to be 30n divided by 2, and if you want to go straight to 15, I'm cool with that also, times the first term plus the nth term, which is the 30th term, which I do not know. But don't I know how to find the 30th term? Didn't you just take a quiz over it? The 30th term is equal to the first term plus the difference, which in this case is increasing by 3, times n minus 1, 30 minus 1 times 29. Everybody find the 30th term for me real quick. Take 4 plus 3 times 29. Morning, I'll let you tell it to me if you have it, because you looked at me like you did. What is it? What is it? 120. Do I have an agreement on that? Let's see. I don't think that's... Yeah, that's not... So 3 times 29. Yeah, that's definitely... That's okay. That's why we're going to wait for an agreement. What do we get, Noe? 91. That sounds better, doesn't it? Okay, so then I can take this 91 and put it right here. Okay? Now let's find the sum of the first 30 by simply taking 15 times 95. Hannah, when you have that crunch, I'll let you say it. 1,125. Do I have an agreement on that? 425. Do I have an agreement on that? Yeah, I could see Ryan was making a face. So, there we go. We good? All right, let's do another one. So if I say find the sum of the first 40 terms of this arithmetic sequence, so I'm asking for the 40th series, I'm going to say the sum of the 40 terms is equivalent to 40 divided by 2, as Gauss taught us. He took the number and divided it by 2, times my first term is 50. I don't know my 40th term. Let's go off to the side here. Let's find the 40th term by using the first term of 50 plus our common difference of, what was the common difference this time, guys? It's negative or 8 times, that was Brooke Lee that yelled out a random wrong answer. That is recording. So, and then redeem yourself, Brooke. What do I multiply by? Negative 8 times, no pressure. This is the... Don't help her out. Leave her hanging, Gabby. Let her. No, we're all staring at you. It's n minus 1, Brooke. 40 minus...
39.
39, good. I was going to do the arithmetic for you. You definitely what? No, you didn't. Nobody in here, not in this room, nobody failed ISTEP. You guys are the cream of the crop. Okay? Or you're really good at faking it, one of the two. Then, what is that 40th term? Anybody have that crunched already? Hope you have that crunched already. Do I have an agreement on that? Yeah, so negative 262. Uh-oh. Okay. And then I'm going to take that 40th term, and I'm going to plug it in right here. And now I'm going to find the sum of my first 40 terms by simply taking 50 plus negative 262 times 20. Michael, you got it for me?
I got it. Negative.
It should be a negative.
Negative 4,240.
Do I have agreement on that? Negative 4,240? Nice. What do you guys think?
Got that one.
Okay, that whole 40 minus 1 thing, we'll get that eventually. Okay? Other good questions for me. All right, let's keep it going. I think we're okay with these type. Let me get to the next strategy. I'd say right here we are. So here I tell you the 11th term's 53. The 5th term's 23. I'm asking you to find the sum of the first 25 terms of an arithmetic sequence. That's key, right? Okay. Well, this is what I know. I know the sum of the first 25 terms is going to be 25 divided by 2 times. Oh man, I need the first term, I need the 25th term. Probably, what's the thing we probably should do first? Let's find the what first. Ryan?
Well, I'm not quite sure what Paul plays, how much increase and decrease.
The difference, the D, that D thing. And how do we find how much it's increasing or decreasing? What would I do here? It's simply the slope, right? I'm going to take the 11th term, 53, minus the 5th term, 23, over 11 minus 5. Let's see, I get 30 over 6, which is 5. So I'm increasing by 5 units. Agree with that? Now, Easton, D is 5. You okay with that?
Yes.
I bet you're smart enough to, in your head, think, okay, if the 5th term's 23, 4th term, 3rd term, 2nd term, 1st term. What's the 1st term? I'll hit pause. That the 1st term is 3. Okay? Now, I don't think I'm going to actually write it down. I'm not going to think how many more times is 25. I know you totally can do it. I'm with you. I would too. But I am going to make sure we have the 25th term by knowing the 1st term is 3 plus 5 times. This is what you're going to do in your head anyways, wasn't it? You're just going to take 25 minus 1. Brooke, what's 25 minus 1? Good job. See? And then you're going to go, what, 5 times 24 more times plus 3. What's that 25th term? Anybody have it? Gabby, you have it? You're just sitting there. I thought you had it already.
123.
Oh, good job. So then I can take that first term of 3 plus the 25th term, which is 123. Go ahead and solve for me now, guys. The sum of the first 25 terms. Lexi, you have it already?
Yeah.
What do you have, hon?
I got 1,575.
1,575?
Yeah.
Do I have an agreement out there? Yes? Good. Nice. Lexi supposedly had a big-time game last night. I know I saw multiple hits and a big out in the 6th inning or something. What'd you do in the 6th inning? What was the big out? It always feels good, right? And that's how you finish the inning?
Yeah.
Good. All right. Let's see here. So there's one similar to that. Let's keep going. Ooh, what is that? What is that garbage? Okay. This is not garbage. This is beautiful. This is beautifulness. What Greek? Anybody know what Greek letter this is? Sigma. What's sigma mean? Sum. Oh, Vibo's on that math club, isn't it? That's where it's coming from.
Also physics.
Physics. Okay. So everybody, engineering terms, yeah. So this means sum. Sigma means sum. So what this means is you're finding the sum of the first 20 terms of this arithmetic rule. It's actually really, really easy. You're like, I love these. So, what's this mean? This means the sum of the first 20 terms. Hey, we know how to do that. We go 20, don't hurt yourselves, divided by 2 times, and this is the part y'all freak out over. Guys, all I do is this. This is the arithmetic rule. I follow my cursor. I plug in 1. That's my first term. So 5 times 1, everybody. What's 5 times 1? 5 plus 3, everybody. 8. You guys, when I say everybody, you guys must think somebody's name in here is everybody. Okay? Let's try this again. We also need to find the 20th term. Now, this is going to be really big boy math. What's 20 times 5? 100. Plus 3. All right, everybody crunch the number for me. Go. Shane, when you have it, yell it out to me, bro. 1,110. I like it. You all good? Okay. Let's keep it going. Let's go to the next problem. I want you guys... Okay, what did we get? What did you guys all get? Okay, I gotta write this down here. Let me turn off my freeze. Uh-oh, come on back. Come back. Come back, baby. It's not coming back. Was that it right there? No, that's not it. Was it this one? Okay. What'd you guys get? 4,794. Hey, it's still not there. What's happening? Did you break it? I'm blaming Vibo. All right. Hey, you know what? Was this the answer? Okay. Oh, hey, look at that guy. All right, let's go. All right. So let's do the next problem. I'm gonna skip this one. No, actually, you guys go. Solve it. Go. Am I allowed to keep it up there? Yeah, but then I don't want to tell you how to do it. I know, I'm telling you right now. Hope you guys can figure it out. What was the problem? 15? What was my rule? Negative 10 minus 3n? It's under math. Summation. Oh, I think I typed it wrong. 3x. Negative 510. It's under math. Yeah, it's number 0. Good. Then I just use x instead of n. Makes life easy. There you go. Isn't that wonderful right there? Feel free. If it's a calculator. Now, if I don't let you have a calculator, you got to deal with it. Be able to do it both ways. Because of time, I do need to get to this next problem. I want you to look at this one. So I know you're all worried about your calculator. I'll do it with the calculator for this one too. But look up here. What's different about this one? It's starting from the n equals 4. Now let me give you a little context. What that's saying is, here's my first term, second term, third term. You're going to start with the fourth term all the way, all the way to the 70th term. Okay? So you got to be careful. It's the sum of not 70 terms. It's the sum of how many terms? It's not 66, is it? You're starting with the fourth term and finishing with the 70th term. That's the sum of how many terms? If this was 70 here, 67 terms. Ooh. So this is the sum of 67 terms. Careful with that, right? So it's going to be 67 divided by 2. And then you'd have to find your fourth term. So how would you find the fourth term? You just plug in 4. What's 5 times 4? Plus 3 is 20. Plus, plug in the 70th term. Let's see, 70 times 5 is what? 350. Plus 3, 353. You guys crunch it real quick without using sigma. Without using sigma, real quick. And then I'll go to my calculator and I'll find the math. We'll go to, messed up. Math sigma, which is the summation of x to the 4th to the 70th of, what was my arithmetic rule? My arithmetic rule was 5x plus 3. Did you guys get this as your answer also? Okay. You should have. You should have if you did it correctly. So, heads up. Be aware of it. What time do we get out of here? At 16? I thought it was 21. We're in here till 21. We have 5 minutes. We got all kinds of time for fun. Okay, I'm going to skip this one because it's common sense. Let's go to the next one. A student has taken 3 math tests so far. His scores for the first 3 are 75, 79, 83. What will be his total score for all 6 tests if this trend continues? Wouldn't that be nice that you guaranteed a trend continuing of increasing your math grade? I mean, I guess you have to start with a 75, but we recognize that we're going 75, 79. Let's just write them out. 83. How's he increasing? He's increasing by 4, so 87, 91, 90. What would that last one be? Okay, that's a great dilemma. Ready? Would you be okay with this situation that you're guaranteed to increase by 4 percentage points every test, but you have to know your first test is a C?
No.
Maybe, maybe not. Well, here's what I would know. Let me ask you this. Find the sum for all 6. What's his total score for all 6 tests? Let's add those up real quick. We don't even have to use the sum of 6. Just add those up for me real quick. Obviously, it's the same thing as S of 6, which is 6 divided by 2 times 75 plus 95. What did we get for that sum? Irvi, what's that sum? Quiet.
510.
510. Can you all divide by 6 for me? What is that average? Now, knowing that your average would finish as an 85, would you take the deal? That's a great question. Guaranteed average score for those 9 weeks is an 85 in your test category.
That's pretty much what it is.
Some of us would be like, absolutely. That is way better than where I'm living right now. Right. What about, oh yeah, but that's the 9 weeks. That's what so does your final become a 99 then? Would you take that deal then?
Oh, yeah.
I bet you would.
Oh,
Yeah, I
for
bet you
sure.
would. Nobody likes finals. You guys, nobody likes them.
Guarantee a 99 on my
There is